right, here we go. All right, welcome to 5 Live Free Code School. Okay, so we have one more who's going to arrive. And I've got a couple of people that may join to get us back up to our complement of 5. I'm going to see what the story is with Jason, so whether he's permanently going to be away. I really want him to be part of the long-term class, so we'll just check on him. All right, so where we're at is SQL and databases. So first quick question, were either of you able to make any more progress on getting through the W3 Schools MySQL tutorial?
I've gotten to the joins area.
Good, excellent. And Jonas?
Yes, up until the MySQL min and max area.
Oh, good, excellent. All right, good, that's excellent. What I want to do today is just start to get kind of familiar with the reference database or sample database called Sequila that's built into the community edition of MySQL Workbench, just so that you have an opportunity to practice some of the stuff you're learning in that tutorial on a slightly more complex database and clearly a database that's on your machine. So I'm going to share my screen and pull up the database, and I'd like you guys to pull it up as well. Let me know when you have the database pulled up.
It's up for me.
All right, so the first thing we're going to do is just going to explore a little bit of its structure and its contents. Now, to really understand what this database is, we need a bit of an understanding about what kind of a organization it was created for. And so we're going to have to go a little bit in a time machine back about 20 years ago when video stores were a thing. Sequila is a database for a company that owns a couple of video rental stores. How many have either of you actually rented videos? Are you old enough to have done that?
Yeah.
Jonas, have you ever done that?
No.
Okay, do you know what we're talking about?
About video rentals.
Yeah. It's okay if you don't.
Yeah, but
Okay.
I know the story. Just
You know,
have,
okay.
They have databases about the different kind of movies. They are genres.
Exactly. And it used to be, oh, good. Here's Sudesh. It used to be that you would go into an actual store and rent an actual VHS tape and take it home and play it in your VHS player.
Yeah.
Alas, those days are old. It was kind of fun to go out on a Friday or Saturday night and choose what you're going to do. But I love streaming. So, hey, Sudesh, welcome.
Hi.
What we're doing right now is we're going to practice some of the basics of SQL, but we're going to do it inside this sample database called Sequila that we all have installed on our server. And we're going to access it, of course, using MySQL Workbench. So go ahead and pull up MySQL Workbench and access the database.
Yeah.
Let me know when you're there so I know you're all caught up, okay?
Yeah.
All right, good. Okay, so we're going to look through actually most, if not all, of these tables today. We're going to, again, this is real simple, just to get you thinking. I need a code editor. So on this little icon on the left here, I want everybody to follow along with what I'm doing. If you roll over, it says create a new SQL tab for executing queries. That is what I want. So click on that. And now I have a new tab. Now it auto generates a name for the tab, right? If I were to save this file, the name of the file would be shown instead of this auto generated name. But right now, this is not a saved text file or SQL file. But a thing to stress here is that you could in fact save this and it would just be text content that was SQL commands. And you could open it up inside this MySQL workbench and run those commands. We did that actually for Alexandra's machine, if you recall, right at the end of the day the other day. All right, first thing I want to do is I just want to see what's inside the actor table. So Jonas, I'm going to put you on the spot. What is the, and if you need to look anything up, that's what the internet is for. What's the syntax for me to see all of the contents of this actor table?
We would write select asterisk from actor.
Okay. Now, one thing about MySQL is it does get kind of picky about semicolons. Not every code editor does, but in general, when you are done with a complete instruction, you should put a semicolon. You'll notice that it might run without it, but the code editor gets really upset if you aren't using semicolons at the end of every complete instruction. All right, now, this may or may not work. And the reason for it is that I am using this MySQL workbench and I'm opening up a little tab that I can execute queries. But I have on my server at least 1, 2, 3, 4, 5, 6, 7 different databases. So when I run this, it might not know which database to run it against. Now you'll see down here in the bottom left, I have under an information panel, the fact that the selected schema is Sequila. I happen to click on it. That's why it's in bold. Here's some just lessons learned over the years. Always have the first instruction be the use statement where you specify the database you want to operate against. The reason for it is you want to prevent the possibility of accidentally running your commands against the wrong database, the one you don't intend. So if we do use Sequila right here, now whenever we run this code, the first instruction is the use command, and every subsequent SQL instruction, we've guaranteed it'll be applied on the database we want. So remember that this lightning is to execute the selected portion of the script. So let's click on that. And look, here are the results. I get all the columns. How do I know I have all the columns? How could I check what the columns are using this MySQL workbench? Sudesh, any ideas? What do you think, Sudesh? Can you hear me? Yeah, we're not getting your audio, Sudesh. While he's debugging that, Jonas, do you know a way we could see what all the columns are in this table?
Yeah, I mean the syntax.
I'm not looking for a SQL instruction to do it. I'm looking to leverage this tool in front of me called MySQL Workbench.
Okay.
And if you don't know, that's fine. That's part of why we're doing this case.
There are the head, actor ID, first name, last name, and last update.
Right. We see them right here. Where else would those columns be listed or shown in this display? Any ideas? Sudesh, can you hear us? Yeah, we
Yeah.
can hear you now.
Yeah.
Okay. Sudesh, do you know where in this user interface we could see a list of all the columns in a given table?
Yes,
Where?
it's the actor ID, first name and last name.
Yeah, we see them right here.
Yeah,
That's because we have results.
yeah.
Now we don't have them. Where could I see the columns?
On the left-hand side.
What do I
under the
do?
table. Under the table.
What do I do?
Select.
How? What do you mean select?
Are you referring to the command
Nope,
syntax?
I don't want to use any SQL to do it.
Okay. So if you select under the table, all the subsections are columns.
How? Where should I click?
Actor.
Hey, look down there.
Yeah.
There's my columns. I can also expand this. There's my columns. There we go.
Right.
Perfect. All right. Now we're going to explore a lot more of these little abbreviations afterwards. Have you guys gotten to the concept of keys and primary keys yet, as you've been moving through that tutorial?
I have hints from my classes at school.
Yeah, you know it from your education, totally. But in that
Yeah.
tutorial, we haven't gotten that far yet, right?
Yes.
Okay, good. That's fine. All right, good. So leverage the power of the tool, because the tool called MySQL Workbench has fully scanned the structure of the Sequila database. Remember, the schema contains both all of the objects in a database and their relationship to each other. That's in a schema. And so these are schemas. This tool behind the scenes reached out to the server, the database server, and got all the information about the databases. So we can drill down in here to all kinds of information. We can go to the category table and look at all the columns. Okay, good. All right, so let's replicate. Let's give ourselves a tab again. I deleted mine. Let's look at the select star from actor again, and help if I spell select right. All right, so when you run this, notice these columns here. The first name and last name is the data that we kind of care about a lot. It's the name of the actor, right? But I've also got this actor ID here. Now, can anyone tell me what the purpose of this column called actor ID is?
I guess it's a unique identification for each row or record.
Yeah. Every entry in this table is called a row or a record. And it's good practice to have a unique identifier for each row. There's a possibility that there might be two actors with the same name. And we want to be able to differentiate. We might even have two actors that have the same name and they were updated at the exact same time. That might be possible. So if we have a column on here where each row, each entry in this table has a unique number or other identifier, now we have something unique we can identify one of the rows by. And that comes in very, very, very valuable. Now, let's do some more selecting. Let's open up another tab by going up here, create a new SQL tab. And now I want to see all of the contents of the film table. Alexandra, what's my syntax for that?
Select and then the asterisk. And then you said,
Absolutely. Yep. And then what?
you said for the film table,
Yep.
select asterisk, and then from film.
Okay, good. Now, it's common in the dev community to say star. It just comes off, it flows off the tongue a lot more easily. So we select star from. It's not a star, but it makes it a lot easier to say than asterisk.
Yeah.
Also, not required, but let's specify what database we want to have. If we run this, remember, you should all be following along. Here we go. So here's a movie, a description, when it was released. Oh, now there's something interesting. We have a language ID. We have some original language IDs. We have a rental duration, probably in days. The rate, how much it costs to rent it. How long it is, that's probably in minutes. Yeah. How much it costs to replace it. It's rating. Now, for those of you who aren't in America, do you have ratings for different movies that come out, like for what audience should be allowed to see them? Do you have that, Sudesh, in England?
Yeah,
Does it use the same sort of rating system?
yes, yeah.
Okay. Jonas, what about you in Ethiopia? Do they have ratings for different entertainment?
No, we don't.
Okay. Have you heard of these before?
About ratings?
Yeah. For
Yes.
films. Good. Excellent.
Yes.
Okay. All right. Parental guidance, general, no children under 17, I believe that is, and R for restricted. So parental guidance, general, no children under 17, and parental guidance recommended 13 years or older, and restricted. That's what I remember. We could probably look it up. And then there's a list of special features. Now, this special features is kind of interesting and it's worth talking about. This is just alphanumeric data. It's just text. But I'd like to point out something kind of interesting. There's multiple pieces of data in one column. Look at this one right here. This is one column for this row, and it happens to have 3 pieces of data in it. If you wanted to display on a screen somewhere those 3 different special features, you'd have to find a way to separate them and turn them into 3 separate pieces of data. Any questions about that concept? How might you do that? Never mind an exact language or whatever. If you needed to write some sort of a program to take these 3 things, trailers, deleted scenes, and behind the scenes, and list them separately on a screen, how could you handle the fact that you have one string here? All it is a string that says trailers, comma, deleted scenes, comma, behind the scenes. What could you do?
A break.
What do you mean by a break? I think you're on the right track, but tell me what you mean by a break.
It's like in the code, we do a line break.
Right,
and
but how are you going to separate out the three pieces of data? A line break is good for first one, line break, then the other, line break, then the third. That's what you're talking about, right?
Yeah.
Good. How do you separate out this one long string into three separate strings?
Is it
Conceptually.
using because there's a comma using the comma and
Yeah. Yeah, you're totally on the right track. This data is written in a format called comma separated values, or CSV. It's a pretty common thing to do in programming. They're jamming multiple pieces of data here into one storage location, if you will. And then they're relying on us as programmers to read through it with a program and split it apart using the comma as a separator. Make sense?
Yes.
Now, we've done something similar when we built our CRUD application. You may remember how we did something similar. We split something apart. Let me show you that. We go here, open recent, and go down to complex. This is our CRUD application. And look, here's our database information. Each item is on a separate line. If we look at our import database code, right here, we do a split. First, we read the contents of the file and assign the contents to this variable called contents. Then we make an array by going through the contents, and on every carriage return and new line, splitting apart the contents into separate items. You could split on a comma. And again, it isn't the exact syntax that's correct that matters here. I just want you to be able to think with the concept. That's all. All right, let's go back here. We're just kind of familiarizing ourselves with all of these columns. Now, something kind of interesting here. We have a language. Now, they didn't list the language. They just said one, or let's go down, scroll down. Looks like they're all language one. How do we know what that language is? Any ideas? It's okay not to know. We're just talking through this.
Could it be in language table?
Yeah. Let's all open up a third tab here. Remember to specify your database. And then, Sudesh, what's the syntax to select everything from the language table?
Select asterisks from language. Semicolon.
All right, let's run this. Oh, look at that. We have 6 different languages that we have in our database. And notice that English has an ID of 1. Well, now we're going to get to our first little bit of fun. Remember that when you're reading information from a database, a lot of the times reading that information so you can present it to a user. So I ask you, like everybody go back to the other tab where we selected from the film table. Everybody there?
Yes.
We have all these available columns. Now, we may not want to, let's say we have an application where you can search through all of the available movies so you can figure out which one you want to rent. If we're looking at a page that shows the details for a specific movie, let's look at these columns and think about which ones might we want to put on the screen. We might want to put the ID, but our users aren't going to care about that too much, right? But we're certainly going to want to put the name of the movie. We'll probably want to put a description so they can read through and figure out where they want to rent it. Do you think we will often want to put what year it was released?
Yeah.
There's no right or wrong. I'm just interested in your guys' thoughts. Can anybody think of a reason why it would be helpful to a user to see the release year?
Yeah, there may be more than one release.
Yeah, absolutely. What if it was a remake? Am I going to look at the old one or the new one? That's a great point. Okay, good. Now, let's look at language ID. Is it going to be helpful to say language ID and show them one? Is that going to help a user at all?
No.
No, not at all. Okay. Rental duration. Do you think people are going to want to know how long they can rent the movie for?
Yeah.
Absolutely. All right, good. And then they probably want to know how much they're going to pay for it, right?
Yeah.
And how long it is. Do you think they're going to care about replacement cost if they're trying to select a movie to rent? What do you think?
Yeah.
Okay. Anybody else have a different opinion?
Replacement cost. I
Yeah, if
have
they
no
lose
idea
if
what
they
it
lose the
means.
movie, that's how much they have to pay to replace it.
Okay.
Oh,
It's not
this
that
is
common.
Go ahead, Sudesh.
this could be a digital rental, isn't it? I'm thinking
No, this
about.
is an actual physical tape.
Okay. Yes. Then.
Okay, yeah, they might. That's totally a decision that the people making the program could make. All right. They'll probably want to know the rating. They can decide whether or not they're gonna, if they got young kids at home, maybe not gonna rent a rated R movie.
Mm.
So are they gonna care about when we last updated this entry in the database?
No.
Yeah, not gonna care. All right, so what I want to do first is instead of selecting all columns, let's select the ones we care about. Now, I don't like to have big, long code that goes off to the right. It's not very easy to read. So when I do my selects, I do it like this. I have them one after the other. So what's the first column we might want to grab? And everybody follow along and do this code as well.
Yeah, title.
All right. Next one.
Mm,
Description.
description.
Absolutely. We said we might want release year, right?
Yeah.
All right. We're not going to do language ID because the number 1 doesn't help us at all. We want rental duration. That's right. How long will they have it? How much will it cost? Make sure you're following along and doing all this.
Sorry.
And we want length. And we'll want replacement cost. Let's move this to the right. And we want our rating. And we want our special features. And that's it, because we don't want last update. So now we're only going to select these columns, not every column, because we think this is what our users might want to see. Let's try to run this. Okay, I like this. This is a little better. Okay. We have our title, our description, our release year. If any of you ran into an error, let me know. All right. So now, go ahead.
I don't get the table.
Okay. Down at the bottom here in the action output, do you see some kind of an error?
Yes.
What does it say over in the message?
Select title, description, release year, rental from film. Okay, I think.
What does it say on the not on the left, on the right under message?
Well, okay, 1064. Your
Is there
name.
any, go ahead. Sorry.
You have an error in your SQL syntax.
Okay.
Get the manual.
All right. Go ahead and share your screen. I'll stop sharing mine, and we will figure it out. All right. Now stop for a moment here. And first of all, just look at your code editor and see if it's helping you in any way. So my question is this, on line 13.
Yeah, that's.
What is the star for? What does star mean in a select?
Everything in films.
All columns, right?
Yeah.
Do we want to select all columns?
No.
Good. Then make that star go away. Hey, look at that.
Right. Thanks.
Good job. Awesome. Now, another valuable lesson there. Let me share my screen. Remember, I'll replicate it. You had an error right here. Oh, it's going to give it right there. He said it was on 13, right? Is that what you had? Okay.
Yes. Yeah.
Sometimes the error is right before the referenced word. Like if we roll over this, yeah, that's not helping much. No, you just have to scan through it and check your syntax. All right, so any questions so far about what we're doing here? We're choosing which columns we care about, right?
Yes.
Okay, now, here's a real problem. I'm making up a problem. The people that we're doing this program for have said, listen, we have to know what language the film is in. So we've got to figure out a way to find out the actual word, like what language each film is associated with. Can anybody tell me what tool we might have in SQL that could help us do this?
I think we have to use the where clause.
Tell me a bit more about what you think here.
For instance, we would say select a column
Mm-hmm.
From some table where
So we have
Where?
select these 8 columns or 9 columns from film, right?
from film where the language IDs ID equals single quotation,
What's that? Single quote?
single quote.
Yep.
English. Now we goes yes,
Okay. Now,
because it's a string.
okay, good. So this isn't going to work. Can anybody tell me why? I'll run it. You're going to get 0 results. Look at that. No results. Can anybody tell me why?
Would it-
Go ahead, Alexander.
Okay. Would it be because the language ID is a number, so we would need like a join to be able to get the actual string from the language table?
Exactly. So I want everybody to have done this. Everybody be coding along with everything I do, you guys do, okay? So let's take away the where with the semicolon back, run it. And I kind of want to see what the language is anyway. So right at the end here, I'm going to do comma language ID. I just want to see what it is. That's not what I want to send back to the user, and we'll see to whatever program needs the data, and we'll see why. Run this, and what do we have? Scroll to the right, and yeah, that's super not helpful. It's a number. Now, Jonas, do you see why the where clause didn't work? We were looking in the film table. And you're saying this. Well, are there any rows in this table that will ever have a language ID of quote English, unquote?
Okay. Yeah, they don't. It's
Yeah.
only in number.
Exactly. Now, the reason why is that we have decided to separate out 2 types of data into 2 separate tables. In this film table, we only want data about films. In our language table, we want data about languages. We might want to use this information other places. For example, we could, and we don't, but we could have a column in our customer table called primary language, and we could record what the language of that customer is. English, French, Spanish, German, whatever. We might want to have that. So we've decided to separate out language information and put it in its own table. Remember, we did that. You guys should be able to look here and see the language table. And here's our 6 entries: English, Italian, Japanese, Mandarin, French, and German. So let's go back to our film table. We are using this column here called language ID to have a special function. We're not storing the actual data there. We're storing a way to look up the data in another table. Another informal description for this kind of a column in a table is it's a lookup column. This column refers to another column. It refers to a column in a different database. So we actually need to connect these two databases. We need to connect these two tables, film table and language table. We need to join them together. So let's figure out how to do that. So we'll go very slowly. If you have any questions, let me know. And you guys will have plenty of chances to practice this. So we have here a select. We know the table we're selecting from. It's the film table. We know which columns in that table we want to select from. Well, now I want to connect the film table to the language table. And I do that, as one of you mentioned, using a join. It's a SQL operation. So I'm going to do join, and I'm going to join to the language table. Now, I've got to specify the column in one table that I'll connect to the column in the second table. Which table do I want to see a connection established by? The table that we have in the film, the column we have in the film table that should connect us to the language table is called language ID. You see that?
Yes.
So we can go and specify the columns. We can go film dot language ID. And wherever the contents of that column equal the contents in the other table, which is called language dot language ID, wherever they're equal, we'll connect those two and get all the columns we want information on. Well, let's look at this language ID here. That wasn't very valuable to us. Well, now that I'm connected to the language table, I can actually get columns from that table. I can go language. That's the table. See, look, it even helps connect me. Dot, and then I want the name. Catch up to where I am. Anybody not caught up to where I am before I run this? All right, then let's run it. And let's go to the right. And look at that. We have the actual name. We got that. Now, this collection of data down on the bottom here is called our result set. It's shown in a grid, so they call this a result grid. Now, this next part is super important. You can take a result set or a result grid and treat it like a brand new table in many ways. This table has the following columns: description, release year, rental duration, rental rate, length, replacement cost, rating, special features, and name. Now, we don't have an actual table in our database that looks like this, do we? There's no table in the database that looks like this. But we just did something pretty cool. We made, you can almost think of it as a temporary table. These results that we get back are a temporary table, conceptually. And in this table, we have rows, just like any table. This first row is this movie called Academy Dinosaur. And these columns that you see, the information in them happened to come from, for the most part, the film table. But, and again, I want to say this very carefully, these results, which are considered like a table, in this row, the data in this column called name came from the language table. And we were able to reach over into that language table and get this information because we joined the two tables and made a new row whenever the current row's language ID was equal to a language ID over in the language table. Any questions about this? You're going to see lots of joins. So if you have questions, it's okay. Anybody have any initial questions? All right, so let's add a couple of things. This column name over here called name isn't very helpful. I want to give it a name that's more descriptive. So this line, line 13, is what's responsible for obtaining that data. I can rename the column in the result set by going as and then giving the name. I like language name. Now that's a lot more helpful to me. Name is not helpful. One of the reasons why is it might get confused with title. What's the title of the movie? What's the name of the movie? I want to be extremely specific with the name of this column. Let's run this. Make sure you make the change. And now scroll to the right. Holy moly. Now in our result set, which again can be considered a brand new created temporary table. In our result set, this table has a column called language name. That's kind of valuable, right? Good. Now, I could rename any one of these if I wanted to, but I like the names of them. They make sense. So let's look at another common convention when you're doing these joins. Remember, up to this part, make this smaller. I gotta give myself more room. Up to this part, the highlighted part, well, let's look at the select. This looks really familiar to us. Select these columns from the film table. Now, though, we want to join to another table because that table has information we need. We need information from the language table, so we're going to join to it. I've specified the table I want to join to. In this case, it's a table called language. And I've specified where to look in each of the tables, the film table and the language table, for which column in each of those tables to join together on. Now, A more common way to do this is when you're specifying the tables to give them an alias using this as command. I might do F for film and L for language. Now I can rewrite this as F.language ID and L.language ID. Now that works in other editors. Let's see if it works here. No, it's mad at me. It did not like it. Unless oh wait, could be wrong. Oh, when I do that, I have to use that same alias up here when specifying the language table. Let's see if it works then. Look at that, that worked. So, give myself a little more room here. I want you all to see that. I made an alias for the film table because I didn't want to type out film every time. I made an alias for the language table. I didn't want to type out language every time. And that way I could specify the table and the column. The table and the column. It just makes your code a little bit easier to follow. Any questions about that use of aliases in naming the tables that you're going to join together? All right, so let's practice another one. Let's look at a whole nother set of relationships here. I have actors and I have films. How do I know what film an actor was in? Well, I have this little lookup table here called film actor. So go back to your first tab. You should have actors right here. So we know all of our actors. Oh yeah, Penelope Guinness, great actress. All right, I want to see all the films. So let's open a new tab. Remember to specify your database, and then it's select star from film. Run this bad boy. There's all my films. Okay, all right. We should be kind of familiar with this table already. We just did something cool with it. Let's go look at the actor. So each actor has an actor ID. Okay. Look at your film. Each film has an ID. Well, remember that this film ID 1 has absolutely nothing to do with the fact that this actor ID happens to be 1. These numbers for actor ID were automatically generated each time we added in one more actor. It just incremented the number and used that as the ID. So how do we connect these? How do we figure out which actors were in what films? In this little table here, called a lookup table. This film actor table. If you look at the columns, it has an actor ID and a film ID. Let's see what that looks like. Open a new tab, and let's look at all the contents. Remember to use tequila and select everything, star, from this film underscore actor table. And let's start to analyze this. Now, this is actually pretty interesting. Let's read this. This first row means that the actor with an ID of 1 was in the film with an ID of 1. So it turns out that Penelope Guinness happened to be in Academy Dinosaur. But let's look at the next one. The actor with an ID of 1 was also in a film with an ID of 23. Let's look at our films and look down here. So she was also in Anaconda Confessions. Oh, that's a real classic. Look again. She was also in film ID 25. She was in a lot of films. Look at that. She was in all of these films. She's very popular. So here's what we're going to do. I would like to write a query that tells me the name of every film that Penelope was in. That'd be kind of nice, right? That's what we're going to build. So let's get a brand new clean tab to do that. Remember to specify your database and spell it correctly. Now, before I start specifying the actual columns that I want, I just want to connect up the actual tables I need to connect. And here's how this works. I'm going to go from the film table to the film actor table and then to the actor table. I want to connect all three of them. If you look at let's go back one tab. The film actor table obviously connects to both the film table and the actor table. Conceptually, they connect to them, right? We've made sure that we've recorded all these actor IDs. Those correspond to entries in the actor table. We've made sure to record all these film IDs. Those correspond to entries in the film table. So clearly, at least conceptually, to the people putting this database together, these three tables were meant to work together. Any questions or comments about that? All right, well, let's connect them together. Go back to your new blank thing, and we're going to select everything from, first, we're going to go from film, and let's alias it because we know that we're going to we know we're going to join. So let's give it an alias of F. And let's join it to the film actor table. And we'll give it FA for film actor. And now we want to join yet a third table, the actor table, as A. Now, after each join, though, we have to specify what columns to join on. So make a line here after the first join. Line 5 is the first join. So I have to specify what columns we're looking for identity on. Well, we're going from film to film actor. So in the film table, we're looking for a film ID. And we are trying to match where that's equal to, in the film actor table, the film ID. Any questions about why we're matching on those two columns? All right, well, we have another join here from film actor, which is the last one we were at, to actor. So we have to specify what columns. Well, let's go from film actor. What column do we want to join to the actor table with here?
Film ID.
Film ID to join to an actor table? We're trying to find where the contents of the film actor table are identical to the actor table. We want to see where the actor ID in the film actor table matches what's in the actor table. Let's look at that again. Go back here. Look at this. This is the lookup table. Film actor is meant to be in between each of these tables, the film table and the actor table. It goes in between them. We want to connect to the actor table on actor ID, because that will tell us the actor information. And we want to connect to the film table on the film ID. That'll tell us the film information. And that's what we have here. We've started out in the film table. We joined to the film actor table wherever the film ID in each is the same, wherever they're equal. And then we went from the film actor table over to the actor table. And we've looked wherever the actor ID in each of those is the same. Any questions about this? It's okay if you have questions, believe me. There's a lot going on here. All right, now let's run this. We got a lot of results. Notice we have, let's look at this first entry here of a film ID of 1. Remember, these results could be considered to be a brand new created by us table with its own set of columns. Now, in this case, because we did a select star, we'll get every single column from all 3 tables. Let's watch. Now, do any of you recall for film number 1 who the actor is?
Penelope.
It is Penelope, right? And we know that because when we look here at the film actor table, the lookup table, we know that film 1 corresponds to actor number 1. That is actor number 1 is Penelope Guinness. So we know that. Let's go back to our results and let's go across one column at a time. Remember, we selected every column from film table joined to film actor, joined to actor. Well, let's go across. Here's our film ID. Remember, we're only looking at the one that's in blue, the one I've highlighted. That's called Academy Dinosaur. Here's the description. We've already looked at this in some detail. Scroll over slowly, and we're going to get to the point where we have special features and then last updated. And before we go a second farther, I'd like you to remember that so far, those are all of the columns in the film table. And yet we still have room to go to the right. We have about 3 columns here, 4 of them really. Or 3. Ooh, we have an actor ID and a film ID and a last updated. Where did those columns come from? Anyone? These 3 columns right here, where did they come from? What?
Actor ID table.
The actor ID is not the name of a table.
From the film actor.
From the film actor table right here.
Film. Yeah.
Is that what you meant, Sudesh?
Yeah.
Good, perfect. Yeah. If we look back at the film actor table, well, lo and behold, look at that. Those are the 3 columns of the film actor table. And if we look at our query, we joined from film to film actor. So it makes sense that once we got done right here is where we got done listing off any entries from the film table. Now we're going to go to the next table we're joined to, which is film actor. And here's these three pieces of data. Remember, we're only looking at the first entry, this one that I've highlighted in blue. But we still have room to the right. What do you think is going to be to the right?
The actor table.
Actor, exactly, actor information from the actor table. And there it is. There's the actor ID. There's her first name, her last name. Oh my God. We just got everything from all three tables. Well, remember that we wanted to see all the films that Penelope Guinness was in. So let's add a where clause. Now we have three tables in play. We can do a where on a column from any one of those three tables. What column do you think we care about if we're trying to match for Penelope Guinness? We want to see all her films. What column and what table do we care about?
The latest table we created.
Oh, you mean this one down here?
Yeah.
That doesn't exist. We can't query it right now. We're about to do a brand new query. We have three tables here: film, film actor, and actor. First of all, where do we have in those three tables actor information?
Actor.
In,
In the actor table, right?
Yeah.
Do we have actor information anywhere else?
yes, in the film actor.
Exactly, in this film actor table, which is called a lookup table. We have actor information. Oh my God, there's an ID for an actor. So if we're trying to identify, if we're trying to create a table that contains information about movies with Penelope Guinness, and we have actor information in both a film actor table and an actor table, which one do you think we should do our where clause on? The primary place that we're supposed to store actor information, in the actor table. So remember, we have given an alias to our actor table. We're calling it A right here. You see that? So I can do A dot actor ID. And what is Penelope's actor ID? You may remember it.
See one.
It is 1. So now run this query. Look at that. Here's a bunch of films. There's only 19 of them. We scroll to the right. We should see that Penelope Guinness is the actress on all of them. Now, here's my question. Do you think there's multiple actors in a film? That's just, I'm joking. There are, of course, multiple actors in a film, right? I would like to see all of the actors in this film called Language Cowboy. It has a film ID of 509. So let's change our where. If I want to match on a film ID of 509, what table is that information in?
No,
Film. So use F because we gave it an alias. Dot film ID. And say equal to 509. It's called Language Cowboy. So go ahead and run that bad boy. Ooh, there's 5 actors. This is all for the same film. And we scroll to the right. Penelope Guinness, Bette Nicholson, Christopher Barry, Warren Jackman, Whoopi Hurt, and Cuba Birch. Those are the 5 actors in that movie. And we can get that information super easily because we've joined all three of these together. Now, you have two homework assignments. One is just to continue through the tutorial on W3 Schools from MySQL version of SQL. At every time that you have an opportunity to practice some of those commands, don't just do them inside the W3 tutorial. Find a way you can practice the commands here in this database, the Sequila database. The second homework is, I want you, without looking at the code, to try to recreate the two joins that we did. Now, save these tabs. You can look at them if you're completely stuck, but try to do the work without looking. The two joins are, how could we include the language name if we're looking up a film? So joining the film table to the language table. That's the first join. And the second one is, how can I join together tables so that I can figure out all the actors in a film or all the films an actor has been in? I want you to try to recreate what we did over the last hour without looking. Now, again, I want to clarify. If you're stuck, look real quick and then go back and try to just go, okay, try to do as much of it without looking as you can is my recommendation. Okay. So that's the homework. Now, for advanced homework, if you want some extra credit, try to find 2 or 3 more places in this database, Sequila, where you could do some joins that would give you some valuable information. And keep that code so that when we meet again on Monday, you can show us some interesting joins and explain why you joined it together. What kind of information do you want about one thing that was only available in another table? Explain why you did what you did. So that's your homework. All right. I think I'm going to give you guys 15 minutes back. Anybody have any questions at all about what we've done?
What was the first homework?
The first one is continue with the W3 Schools tutorial.
Yeah.
Practicing whenever you can your commands on the Sequila database, in addition to how you practice them inside the tutorial. The second one is to recreate these two joins that we did.
Yeah.
And the extra credit is try to find some more joins.
Okay. Just a question. I was trying to relate this to what's happening in Netflix.
Yeah.
Because you can select actor or whatever the feature.
Yep.
And get all the films listed. So that's
a great way to relate it. Another one is if you go to IMDb, the Internet Movie Database. So IMDb, and click here. We could look up. Let's look up the actual article. Let's look up Penelope Cruz. And if we look up Penelope Cruz, here she is. It'll have all of her movies.
Yeah.
But we could do the other way. We could go down here and pick Zoolander 2. So we look up a movie and it'll have all of the actors right here.
Yeah.
So yeah, that's a great way to think of it. Absolutely. So I want to point something out. With filling in this information about how to store data permanently and how to look at the relationships between different types of data and how to query that data to get the data you need for a specific purpose, you're filling in one of the key final building blocks for you all to be full stack developers. We're getting close to you guys having a position of like knowledge and power, which is pretty cool. Now we're going to do a lot of work to cement that and build, some things but you're filling in one of the final key, really important building blocks. And I'm really happy for you guys. And I want to help you in any way we can as we fill that final building block in. So during the week, please reach out for help if you get stuck on something. Anybody else have any questions or comments?
No.
All right, cool. Excellent. Well done. Have a great evening. I will see you all next week. And other than that, have a great night or a good day.
Good night.
Okay, thank you. Good
Bye.
night.